dark matter is a mysterious substance that scientists believe makes up a big part of the universe. It's called dark because it doesn't give off any light or energy that we can see. Scientists know that dark matter is there because of its gravity. It pulls on other things in the universe, like stars and galaxies. Imagine you're playing with a bunch of marbles, and you can see all the marbles that are out in the open. But you notice that some of the marbles seem to move in strange ways, as if there are invisible marbles pulling on them. That's kind of like how scientists discovered dark matter. They saw that things in space were moving in ways that couldn't be explained by the visible matter we can see, so they knew there must be something else there. Scientists don't know exactly what dark matter is made of, but they have some ideas. They think it might be made of particles that are too tiny to see, or maybe something we haven't even discovered yet. They're working hard to learn more about dark matter and its properties, so that we can better understand how the universe works. Certainly. Here is an essay on dark matter. Dark matter, the mysterious substance that makes up most of the universe. Dark matter is one of the most puzzling and fascinating concepts in modern astrophysics. It is a type of matter that does not emit, absorb, or reflect light, and yet it is believed to make up a significant portion of the universe. In fact, according to current estimates, dark matter accounts for approximately 85% of the matter in the universe, making it one of the most abundant substances in the cosmos. Despite its importance, however, we know very little about dark matter and its properties. In this essay, we will explore what we do know about dark matter, what we don't know, and the efforts that scientists are making to unravel its mysteries. The discovery of dark matter. The concept of dark matter was first proposed in the 1930s by Swiss astronomer Fritz Zwicky. Zwicky was studying the Coma cluster, a collection of galaxies located about 320 million light-years from Earth, and noticed that the observed mass of the cluster was much less than what was required to explain the gravitational forces that were holding the cluster together. He hypothesized that there must be some unseen, or dark, matter in the cluster that was providing the missing mass. However, his idea was not widely accepted at the time, and it wasn't until the 1970s that new evidence began to emerge that supported the existence of dark matter. In the 1970s and 1980s, astronomers began studying the rotation curves of galaxies, the way that the velocities of stars in a galaxy change as their distance from the center of the galaxy increases. They found that the rotation curves did not match what would be expected based on the observed mass of the galaxy. In particular, the stars at the outer edges of galaxies were moving much faster than they should be if the only matter in the galaxy was the visible matter that we can see. Again, the explanation for this was that there must be some unseen matter, dark matter, that was providing the extra gravitational force necessary to hold the galaxy together. What is dark matter? Despite its name, dark matter is not actually completely dark. It interacts with gravity and can be detected indirectly through its gravitational effects. In fact, the evidence for dark matter comes primarily from the way that it affects the motions of visible matter through its gravitational pull. The nature of dark matter, however, is still unknown. Scientists have proposed a number of different possibilities for what dark matter might be made of, but so far none of these proposals have been confirmed. Some of the most popular candidates for dark matter include weakly interacting massive particles, WIMPs, axions, and sterile neutrinos. WIMPs are particles that interact only weakly with other matter and are thought to be produced in the early universe. Axions are hypothetical particles that were originally proposed to solve a different problem in particle physics, but they have also been suggested as a possible candidate for dark matter. Sterile neutrinos are a type of neutrino, a fundamental particle that is already known to exist that do not interact through the weak force and are thus sterile. Efforts to detect dark matter. Although we do not know what dark matter is made of, scientists are making great efforts to try to detect it. There are a number of experiments underway that are looking for indirect evidence of dark matter, such as the interactions of dark matter particles with other matter or the decay of dark matter particles into other particles. There are also experiments looking for direct evidence of dark matter, such as the detection of the actual particles themselves. One of the most promising experiments for direct detection is the Large Hadron Collider, LHC, located at CERN in Switzerland. Why scientists study about dark matter? Scientists study dark matter for several reasons. One reason is that dark matter is a major component of the universe, accounting for approximately 85% of the matter in the universe. By understanding dark matter, scientists can gain a better understanding of the universe as a whole. Another reason is that dark matter plays an important role in the formation and evolution of galaxies. The gravitational effects of dark matter help to hold galaxies together and shape their structure. By studying the distribution of dark matter in galaxies and how it interacts with visible matter, scientists can gain insights into how galaxies form and evolve over time. In addition, the search for dark matter is a fundamental question in particle physics. Many of the proposed candidates for dark matter are particles that are predicted by theories beyond the standard model of particle physics. By studying dark matter and attempting to detect it, scientists can test and refine these theories and gain a better understanding of the fundamental building blocks of the universe. Finally, studying dark matter can help to address other important questions in cosmology, such as the ultimate fate of the universe and the nature of the Big Bang. Dark matter is believed to have played a significant role in the early universe, and understanding its properties can provide important clues about the early history of the universe and its evolution over time. Overall, the study of dark matter is important for gaining a better understanding of the universe and the fundamental laws of physics that govern it. Daily More.